Alright, so today we'll go to the new chapter called the Binomial Theorem. So basically, Binomial Theorem teaches us how to expand something to the power of a very big number. So let's just say this is to the power of 10. So of course can also be to the power of 20. Alright. Okay, so first of all, there are 5 concepts. The first concept will teach us how to expand basic binomial terms. Okay, so let us take a look. So concept 1. So of course the binomial theorem, if the formula is given as such, okay, so a plus b to the power of n is equal to this plus this plus this, so on and so forth. Okay, and you notice that there's a bracket n1, then there's a bracket n2, and of course the general term is nr. So this is what we call n choose r. Okay, so of course I prefer to write in this way, n choose r. Okay, so what is n choose r? N choose r basically is given this formula. Okay, so n times n minus 1, n minus 2, so on until n minus r plus 1 divided by r factorial. Okay, so r factorial, let's just say I give you an example. 2 factorial itself is 2 times 1. Okay, then of course another example, 5 factorial is 5 times 4 times 3 times 1. Okay, so always start from the number that you are interested in, you multiply until you reach 1. Okay, so of course let us do some example. So example 1, evaluate 5 choose 2. Okay, so 5 choose 2 without using any calculator. So on top we put 5. Okay, at the bottom we put 2 factorial. So 2 factorial is basically 2 multiplied by 1. Okay, so you see that there are 2 terms at the bottom, right? So the top must also have 2 terms. So 5 you need to times 4. Okay, so it's always like if bottom got 3 terms, on top must have 3 terms. Okay, so let's evaluate. So at numerator is 20 divided by 2 times 1 is 2. So 20 divided by 2 is 10. Okay, of course you can use your calculator to check whether it's true or not. You can press 5, then second F 5 2. Okay, then you'll get your answer. Okay, let's try let me give you one more example. What about 5 choose 4? How do we evaluate 5 choose 4 without using any calculator? First of all, same thing, put a fraction. Okay, at the bottom you put 4 factorial. 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, so you notice that there are about 4 terms in your denominator, right? So at the top there must also be 4 terms. So top will be 5 multiplied by 4 multiplied by 3 multiplied by 2. Okay, so every term is like 1 lesser than the previous term. So if you evaluate, so your numerator is 20 times 3, 60, 60 times 2, 120. At the bottom is 4 times 3, 12, 12 times 2, 24. 24 times 1 is 24. So 120 divided by 24 will give you 5. Okay, so this is how you do the n choose r. Right? Okay, let's take a look at another example. Show that 10 choose 3 is actually equal to 10 choose 7. Okay, so of course 10 choose 3. Let's determine this. 10 choose 3 is 3 factorial, right? So 3 factorial is equal to 3 times 2 times 1. So there are 3 terms. Then for 10, of course 10 must also have, the top must also have 3 terms. So 10 times 10 times 9 times 8. Okay, so yeah, so this is your term. Okay, what about 10 choose 7? 10 choose 7 is equal to 10. Okay, let me just write. Okay, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 multiplied by 1. So quite a number of terms, right? 1, 2, 3, 4, 5, 6, 7. So there are 7 terms. So in my numerator, I must also have 7 terms. So 10 times 9 times 8 times 7 times 6 times 5 times 4. Okay. So how do I show that they are equal? You just equate them. Then see. So you can see that when I equate them, 10 times 9 times 8 over 3 times 2 times 1 is equal to 10 times 9 times 8 times 7. Oh, sorry. Okay, maybe I just cancel the 10 choose 7 one. Okay, so you look at 10 choose 7. So you look at, yeah, so there's 7 can cancel, 6 can also cancel, 5 can also cancel, 4 can also cancel. Okay, and now we are only left with this and this. Okay, so now we just write 10 times 9 times 8 over 3 times 2 times 1. Okay, so I proved that actually 10 choose 3 is equal to 10 choose 7. Alright, so this is what we call a symmetric term lah. Okay. So example 3, now we go to basic expansion. So basic expansion of bracket 2 minus x minus divided by 2 bracket to the power of 6. How do we expand? Definitely we do not use rainbow method because it's very tedious. Right? So we use the binomial theorem. First of all, 2 minus x to the power of 6. Okay, so if you look at this, there are about 7 terms in. If I expand everything out, there will be 7 terms. So the first term will be 6 choose 0. Always start from 0. Then after that, you put bracket. Okay, the minus sign will always be with the second term lah. So okay, so what about the 2 to the power of what? Okay, so this to the power is always 6 minus 0. So 6 minus 0 is 6. Then this green color is 0. Always follow. Okay, follow this. Okay, second term will be 6 choose 1. 6 choose 1, 2 to the power, then minus x over 2. Okay, then this one is 6 minus 1 is 5. The green color bracket is just 1. Okay, follow. Next, 6 choose 2. So 2 to the power of 4. 6 minus 2, right? So x over 2 to the power of 2. Next will be 6 choose 3. 2 to the power of 3. 6 minus 3 is 3. Then x over 2 to the power of 3. Okay. The next 6 choose 4. 6 minus 4 is 2. Okay. So minus x over 2 to the power of 4. Okay. The second last term, 6 choose 5. 2 to the power of 6 minus 5 is 1. Then minus x over 2 to the power of 5. Okay, last term, 6 choose 6. 2 to the power of 0. Because 6 minus 6 is 0. Then this is minus x over 2 to the power of 6. Okay, so you just evaluate everything out. You will get your answer. Okay, so let me just evaluate. So the first term will be 6 choose 0 will always be 6, right? 6 choose 0. sorry, it's 1, not 6. 1, then 1 multiplied by 2 to the power of 6. 2 to the power of 6, 64. Okay, plus 6 choose 1 will be 6. So this is 32. Then this will be minus x over 2. Okay, second term. Third term will be 6 choose 2, 15. Then 2 to the power of 4 is 16. Then of course x squared over 4. Our third term. Fourth term, 6 choose 3, 20. 8. Then of course negative x cubed over 8. 2, 3, 4, 5. Okay, fifth term will be 15, 4. Then this will be x to the power of 4 over 16. Okay, then plus 6 choose 5, 6. Then this is 2. And this is negative x to the power of 5. 2 to the power of 5 is 32. Okay, last term, 6 choose 6, 1. Okay, 2 to the power of 0, 1. Then of course your last term, x to the power of 6 over 2 to the power of 6, 64. Okay, so I just continue to manipulate, equal to 64 plus, sorry, not plus, minus, okay, 32, 96x plus 60x squared minus 20x cubed plus 3 3/4 x to the power of 4 minus 3 over 8 x to the power of 5. Last term will be x to the power of 6 over 64. Okay, so this will be your expansion. So first term, second term, third term, fourth term, fifth term, sixth term, seventh term. Okay, so you'll notice that this is in ascending order from x to the power of 0 to the x to the power of 1, x to the power of 2, so on and so forth until x to the power of 6. Okay, so we fulfill their requirement, which is in ascending order. What about descending order? How do we do descending order? Basically, if you notice that one thing is that when you are doing ascending order, your constant term will be your first term. Okay, so let's just say in a bracket there are 2 terms, right? Your constant term will be the first term. Your term with the x is always your last term, the second term. Okay, if you are doing descending order, let's just say example 4, your x term will always be the front. Constant term will always be the second. Okay, so let us try this example 4. Okay, example 4, 2x minus 1 to the power of 4. Okay, so remember, if we have to the power of 4, right? So definitely we have 5 terms, total of 5 terms if I expand everything out. Okay, so 2 to the power of x, not 2 to the power of x, 4 choose 0. So 4 choose 0 is 2x minus 1. So of course 2 to the power of x to the power of 4, then this is 0, plus 4 choose 1. 4 choose 1 is 2x times 2x minus 1. Then 2x is 4 minus 1 is 3. Then this is 1. Plus 4 choose 2. 2x. 4 minus 2. 2. Minus 1 is 2. Okay. Then 4 choose 3. 2x. 4 minus 3 is 1. Minus 1 to the power of 3. Last term. 4 choose 4. Okay. 4 choose 4, 2x, 0, and here is to the power of 4. Okay, so let's simplify everything. The first term, 4 choose 0, always is 1. Choose 0. Okay, 1. Then 16 x to the power of 4 plus, or not plus, minus. So 4 choose 1, 4. Okay, and then 4 multiply by 8x cubed. Third term, 4 choose 2. 6 times 4x squared, okay, minus 4 choose 3, 4 2x. Okay, last term, 4 choose 4, 1. Okay, 1 multiplied by 1, yeah, so it's just 1. Okay, so now simplify. First term, 16x to the power of 4. Second term, negative 32x to the power of 3. Third term, 24x to the power of 2. Fourth term, 8x. Last term plus 1. Okay, so you notice that there are 5 terms, right? So 1, 2, 3, 4, 5. Okay, so you notice that it's also descending order. X to the power of 4, x to the power of 3, x to the power of 2, x to the power of 1, and x to the power of 0. Okay, so this is how you do simple basic binomial expansion. Alright, so you can try exercise 1 to practice on your binomial expansion.